today we're going to talk about some more geometry basics. We're going to start with similar polygons. And there's some important things you need to know about similar polygons. First one is that corresponding angles are congruent. They will always be congruent. Congruent means they are the same size and the same shape. Also, when a polygon is similar, the corresponding sides are going to be proportional. So the angles are congruent, the sides will be proportional, which means they relate to each other. So let's look at example 1. Here's our similarity statement that says triangle ABC is similar, the little squiggly line means similar, to triangle DEF. We know which ones correspond with each other. Correspond means in the same place on a different figure based on this statement. We can also look at this figure and it is marked. So as you see, angle A has one hash mark, angle D has one hash mark. That's how we know they correspond. Similarly, angle B and angle E both have 2 hash marks. Angle C and angle F have 3 hash marks. So let's look at our corresponding angles. So we know angle A and angle D are corresponding. We know that angle B and angle E are corresponding, and we also know that angle C and angle F are corresponding. So now let's talk about corresponding sides. If you look back up here at your similarity statement, AB is going to correspond with the first 2 letters over here, DE. So side AB is going to correspond with side DE. So we can say AB and DE. Can go on to know that BC will correspond with EF. And that leaves us with AC corresponding with DF. Notice that when I said side AC, I made sure to label this one DF, not FD. All right, so we've listed our corresponding angles, our corresponding sides. So now let's talk about proportion. To set this up, we want to look at the numbers that correspond with those sides. So side AB was 6. Side DE is 12. If we set up another one, BC is 4 and EF is 8. And when you have a proportion, you know that you want each side to be equal. Well, this equals 1/2 and this equals 1/2. If I continued on and did AC over DF, I still have 1/2. This is what you call an extended proportion. Let's talk about what that proportion will tell us. That proportion tells us the scale factor. We talked about scale factor before when we did dilations. In this case, the scale factor is the ratio of the length of 2 corresponding sides of 2 similar polygons. All right, so we want to look at corresponding sides of 2 similar polygons. The formula is that you do the image side over the pre-image side. So that means you need to know in this drawing which one was our pre-image, which one was our image. And remember, we learned in dilation, sometimes things grow, sometimes things shrink. So just because it's bigger does not mean that it's your image. So if triangle ABC is the pre-image, what is our scale factor? Well, if ABC is our pre-image, we'll look at this side. That means we would have a 6 on the bottom, and your image goes on top. On our image triangle, it's 12. So if triangle ABC is the pre-image, our scale factor is 2. Now, if DEF was the pre-image, we're going to change things around. So DE would be 12 on the bottom, and AB, 6 would go on top. This time, instead of a scale factor of 2, we have a scale factor of 1/2. Notice that depending on which one is the pre-image and the image, your scale factor is reciprocal of each other. Let's do another example. Here we have quadrilateral ABCD, similar to quadrilateral EFGH. Notice again, I have the hash marks that show you the corresponding angles. You can also see it from our similarity statement. Pause the video for a minute and fill this out yourself. Then turn it back on to see how you did. Okay. Your corresponding angles should be angle A and angle E, angle D and angle H, angle G and angle C. Whoops, I'm going to change that around. I want C first. And then lastly, angle B and angle F. Notice I fixed this one so that I had the same one listed first each time. Our corresponding sides would be AD and EH, DC and HG, CB and GF, and BA and FE. Notice again, I made sure to always start with this one and then go to this one. Order does matter. So what's our proportion? If I do side BA to FE, I'm going to see 9/3, which simplifies to be 3. Is that equal to doing side AD over EH? Yes, both times it would simplify to be 3. And if I were to extend my proportion all the way, you would see that every time it simplifies to 3. So what is my scale factor if ABCD is the pre-image? Remember, pre-image goes on the bottom. So if ABCD is the pre-image, and I'm going to take this side, I'm going to put 9 on the bottom and 3 on the top. And my scale factor would be 1/3. If EFGH is the pre-image, I'm going to put 9 on the top, 3 on the bottom, and my scale factor is 3. Once again, they are reciprocal of each other. All right, let's do one more example. So you can see from your similarity statement that KJL and SRT are the same. If it helps, turn this one around. If we turn it over, and I'm going to draw it a little smaller to fit it, R is going to be your right angle. S is going to go up here, and it's 50 degrees. And T is going over here. And the only length that we know is this 15. All right, so find the scale factor if JKL is your pre-image. Well, we only know one side from over here, so we're going to have to compare KL and ST. So if this is our pre-image, keep in mind, 20 goes on the bottom, 15 will go on top. So our scale factor, when we simplify, both divide by 5, is going to be 3/4. Okay, so now let's find the missing sides and angles. So we don't know this side or this side, but we do know what they correspond with. There's 2 ways to find it. One, you can set up a proportion. So let's say KJ is 12 over RS is unknown. And then we know that KL is 20. Remember, you're going to have to use something you knew. And it's going over 15. It's just a basic proportion. To solve it, you're going to cross multiply and get 20x equals 12 times 15, which 144, plus 3 more, 144, 189. divide both sides by 20. So for this, which was side RS, you're going to get x equal to some decimal. Now, the other way you could have done it, you know the scale factor is 3/4, so you can actually take each side and multiply it by 3/4. So we could have said that 3/4 of 12, or 3/4 times 12, is what? And you learned that that would be 9. So why in the world did I get 9 here? 12 times 15. 12 times 12 is 1. We should get 180 divided by 20. Somewhere I went wrong. You don't make that mistake. Now, you have a 4th example on your notes. Do that one on your own, and we'll go over it in class tomorrow.